First law. Today we're looking at the other laws apart from the first law. We spent a lot of time yesterday looking at the first law. So we will look at other laws quickly as they are applied here. We know what is a chord. A chord is any straight line that runs in a circle from one part of the circumference to any other part of the circumference, but it doesn't pass through the center of the circle. For example, this line. This line is a chord. If we open the board, I show you from the board. If we have a circle, this will be a chord. This line will be a chord. Okay, from one part of the circumference to the other part of the circumference without passing through the center. If it passes through the center of the circle, it will be a diameter. Okay, but if you pass from one part of the circumference to another part of the circumference without passing through the center, it's called a chord. It's called what? A chord. Okay, so that's that for that. Now let's move on quickly. So we know what is a chord from one part of the circumference to another part without passing through the center. We know what is a radius. Okay, when a chord and a radius meet, they make 90 degrees. So all of these basics we already know. Let's go to the problem themselves. We know what is a tangential line. Whenever a tangential line touch any part of the circumference or touch the radius of the circumference, it makes angle 90. So when the tangential line touch the radius, it makes angle 90 with the radius. A tangent makes angle 90. This is the angle 90. So we can show that with the board. So if I draw a circle, okay, and I have a radius, let's say here is the center of the circle, and I have a radius. So this radius, if it met with a tangential line, sorry, my line is bent, okay? If it's with a tangent, then here becomes 90 degrees. Is that okay? Let me take another color. Here becomes 90 degrees. 90 degrees. So when a tangent, this is a tangent. This line is a tangential line. When a tangential line meets with a radius, it makes 90 degrees. So we're going to apply this in the problems. We're going to use this to solve a lot of problems, okay? We're going to look at this when we solve some problem. So when a tangent meets a radius, they make 90 degrees. Now let's go back to the work. Okay, we move down. Let's see what we have. Now what if we have two tangents? See, we extend this tangential line. We extend it straight and we extend the other tangential line. They meet at a point. When this happens, this line will be equal to this line, and you know already radius, this radius is same as this radius. And each of these make 90 degrees. Each of these makes 90 degrees. For example, if we have this, let's say we have a circle. Let's say we have this circle. Okay, and then we have here is met with one tangential line, and here we have another tangential line. So this line, this tangential line will be equal to this tangential line. And here is a radius. Let's say here is the center of the circle. Here is a radius to the center. Here is another radius to the center. Okay, this radius is same as this radius. So this tangential line will be equal to the tangential line. And then we can also join from here, from the center. We can also join from the center of the circle to divide this triangle into two equal parts. We divide this triangle into two equal parts. Here is 90 degrees because a radius and a tangent is 90 degrees. Here is 90 degrees because a radius and a tangent is 90 degrees. Here is an angle. They may ask us to calculate this angle if they give us this one, this angle. Okay, so it depends with the problem, the nature of the problem. So, for example, we're going to look at some problems and we're going to fix them. See, they might this angle, they might give us this angle, or they might ask us to find this angle. Okay, or they give us this one, they want us to find this. But we already know here is 90, angle here, this tangent line X, and this tangent line R. These angles, both of them are 90 degrees. So we will understand this when we solve example. So find the value of angle theta in the diagram below. Now he said we should find the value of angle theta, this angle, in the diagram below. Okay? So if we have this, let's say question 1. Find theta. Find theta, angle theta. Okay, let's say we have a circle. Here's the center of the circle. Here is a radius. Here is another radius. This is the angle theta they want us to find, this place. They want us to find angle theta. Here is a tangential line, a straight line. Here is another tangential line. Here was 25 degree outside angle. 25 degree. And then they didn't put anything here, but we know a tangent and a radius is 90 degree. One of the rules, a tangent and a radius is 90 degree. So I already know here is 90, here is 90, here is theta, and here is 25. And if here this outside angle is 25, the inside angle will be what? The inside angle will be what? This. If here is 25, here will be 25 because they are vertically opposite. You know, when two lines cross, then the angles will be vertically opposite each other. We treated that yesterday. So this will be 25. Okay? So to find this, we will say theta plus this angle theta, this one, this angle theta, plus 90 plus 90. So I can simply say 180, but for clarity, let me show them separately. Plus this 90 degree here, this place, plus another 90 degree here, plus another 90 degree, there plus 25, plus 25 will be equal to what? It's a quadrilateral, right? 1, 2, 3, 4 angles. 4 angles is 360. Anytime you have the sum of angles of quadrilateral is 360. So we say this is equal to 360. So we add 90 plus 90, we get 180 plus 25, we get 205, right? So we say theta plus 205. Theta plus, plus 205 will be equal to 360. So theta, angle theta will be 360 minus 205. Angle theta will be, you move this 205 to the other side, will be 360, or you subtract 205 from both sides. Will be 360 degree minus 205. Minus 205. So angle theta will become 155, right? 155 degree. So that's it. You found it, okay? You found angle theta. So this is the type of some of the questions that you may be getting. Sorry, in the example, but just one of it. You see, the first step is for you to know that the angle outside here equal to the angle inside here because they're vertically opposite angles. So here's 25. And another thing is for you to know that a radius and a tangent makes 90 degree. So here's 90 and also here is 90 degree. The next is to know that this is a quadrilateral. 1, 2, 3, 4. So every 4 side is a quadrilateral. So you equate to 360. Theta plus 90 plus 90 plus 25 equals to 360, which theta plus 205 equals to 360, and when you subtract, you get 155 degree. Okay, so that's that for this type of triangle. So we finished one rule. Now the one we are going is called the cyclic quadrilateral. We just finished the two tangential line. We solved an example with two tangential line. Now we want to look at cyclic quadrilaterals. Okay, cycle theory with cyclic quadrilateral. I'm trying to go very fast so we can solve some questions. Now, what we mean in cyclic quadrilateral is when you have a circle, you have a quadrilateral drawn inside a circle. You have a quadrilateral drawn inside a circle. So you have a circle, you have a four side drawn inside a circle. For example, when you have something like this. Okay, before we go that way, we write the topic. We say cyclic quadrilateral. So you find this type of question in the exam paper as well. Cyclic quadrilateral. Meaning, from the name, as the name implies, you can see that a quadrilateral is drawn in a circle. That's why we call it cyclic quadrilateral. They are not just quadrilateral, they are quadrilateral that are drawn in a circle. Okay? Cyclic quadrilateral. So I abbreviate it cyclic quad. Okay? So what it means is that I draw a circle and then I put a quadrilateral inside my circle. I draw a circle, I put a quadrilateral inside my circle. So I can have, okay, let me use different color for the quadrilateral. So I can have this as my quadrilateral. Okay, this is a cyclic quadrilateral. And we say, whenever you have it, the opposite sides are equal and add up to 180. We say they are supplementary. When you say supplementary, it means they add up to 180. If here is angle Y and the top is angle X, it means angle X and Y, they're supplementary. Supplementary means they add up to 180. So when you say X plus Y will become supplementary, they will add up to 180 degree. So anytime you have a circle and you have a quadrilateral drawn inside it, it's easy. The opposite angles are supplementary. If here is angle A and here is angle B, similarly, A plus B, they are also supplementary. Angle A plus angle B will add up to 180. Angle A plus angle B will add up to 180 degrees. So these are another rule for cycle theorem or angle properties. Another rule for cycle theory or angle properties that we use. In the cyclic quadrilateral, the opposite sides are supplementary, meaning that they add up to 180 degrees. Let's take a look at maybe an example. Okay, let's take a look at an example. Say the circle below half center. Find the value of x. Okay, find the value of x. First and foremost, we have to find the angles for each case. If here is 72, if this place is 72, I don't know if we can draw this one. Let's try and draw this. If here is 72, here will be 90 degrees because it's a straight line. You can see they show 90. So 90 plus 72. First of all, 90 plus 70. That's 160. That's 162. 180 minus 162, that would be 18. So this place is 18. If this angle is 18, this angle is also 18 because they're formed by radius. The base angle will be equal because they're both made by radius. So here is 18 degree, here is 80 degree. So we can find what is here. So if here is 18, then here is also 72. So the angle at the center will be what? 72 plus 72, which is 144. Angle at the center will be 144, right? This one will be 144. Right? Okay. So what they want us to find? They want us to find the value of x. Okay. What we know is that to find the value of x, the moment you know this place, okay, maybe I have to draw it. The moment you know this angle, then we know the whole of this angle. Because here is 18. 18 plus 20, it becomes 38. So we know the whole of this. And we know the opposite in a cyclic quadrilateral. Opposite are supplementary. So 2x plus 4 plus this value, which is 38, equal to 180. Let's draw it. Let's try and draw it and try and solve this problem. I think it will help. It will go a long way to help us. Okay. Question number 2 or number 3. Question number 3. Okay, we have then they gave us here to be 20. They gave us this place, this angle to be 20 degree. And they gave this place to be 2x plus 4, if I'm not mistaken. 2x plus 4. And here's 72. Okay. 2x plus 4 is 2x plus 4. Then this angle they gave us to be 72. And then they say this one is 90 degree by drawing this symbol. Yes, 90 degree. So first of all, this is a radius. This radius is equal to this radius. This radius is equal to this radius. So if this radius is same as this radius, then we can find this place. We can find this place. I can call it angle A, whatever we want to call it. And once we get angle A to be same here, to be same as this value. So you can first of all say A plus 72 plus 90, A plus 72 plus 90 equals to 180, because this is a small triangle itself. Equals to 180. Equal to 180. So let's first of all find that angle A. Why are we looking for angle A? Because they gave us the two values here. We know here is 72, we know here is 90, we can find here. And once we find here, we can find this other side. And once we get here, we will be working towards be able to find x using the cyclic quadrilateral formula. Okay? So you see, it's step by step. When you see cycle problem, you look at them, you try. Even sometimes you rotate the diagram to see Because the way they draw it, you might think you don't know it, but when you turn it around, you might see that you can do it. Okay, so sometimes it looks confusing, but they're not, you can handle them if you know the rules. So this plus this, we say we add this and this together, we get 162. Get 162 equal to 180, right? A plus 162 equal to 180. So you subtract 162 from both sides, then we will get A to be what? 80 degree. If you subtract 162 from, I dropped that step, okay? We get A to be 80 degree. I assume you already know what I mean. Subtract 162 from here, A remains. Subtract 162 from here, 80 degree remains on the right. So we get 80 degree. Now this 80 degree from here is same as here. Let's use a different color, okay, to symbolize that. It's same as here. It's same as this place. So here, it means here is 18 degree as well. Why? Because base angles are same. If the radius are same, then the base angles will be same. If here is 18, this place, this angle is 80, angle A, then this place is 18. Now to find the whole of this angle, this one, the whole of this one, you add 20 plus 18, you get 38. We get 38. We get 38. 80 plus 20. We get 38. And remember, in cyclic quadrilateral, the opposite sides are supplementary. So you will say, to find x, remember the question wants us to find x. The question wants us to find x. And x is here. 2x plus 4 is here together. They say find x. So to find x, what should we do? You remember the law, another law that we've just described or we've just learned. The law says, if you want to find x, in a cyclic quadrilateral, when you add them together, you equate them to 180. So what is on this angle? On this angle is 2x plus 4. So I write down 2x plus 4. 2x plus 4. That's what is on this one angle on this cyclic quadrilateral. Okay? Then the other angle is what? Is 38. The other angle that is facing it, this angle is 38. So I will say plus 38. Plus 38 equal to 180. Why we equate to 180? Because we are using supplementary rules. In a cyclic quadrilateral, the opposite angles are supplementary. They add up to 180. That's the meaning. So now we add this to this, we get 42, right? 4 plus 38, we get 42. So you say 2x plus 42, 2x plus 42 equal to 180. Equal to 180. So you say 2x plus 42 equal to 180. Right? Now you move this one to this side. You say 2x will be what? Subtract 42 from 180. If you subtract 40 from 180, you get 140. Take away 2 after 140, you get 138. Right? So 2x will be 138. To find x, is to divide both sides by 2. So I divide here by 2. Let's use a different color. Divide here by 2. If you want to find x, also divide here by 2. So this one we cancel this. X will remain. And then 2 into 13, we get 6, right? Remainder 1. Into 80, get 9. So 69 degrees. So x is equal to 69 degrees. Or x equal to 69. Okay, so that's the solution for this problem. That's the solution for this type of problem. So it's an application of a cyclic quadrilateral. This question you have to apply cyclic quadrilateral. But to apply cyclic quadrilateral, we must get this angle first. We must get this angle here. Because if you don't get that, because you cannot just say 2x plus 4 plus 20 equal to 180. No, it's not 20. It's the whole of this place. It's the whole of this place you have to get. Okay? You have to get the whole of that place, which makes it 38. Okay? So the x degree will be 69. Okay, let's move to the next one. Another cyclic quadrilateral. Segment. Segment theory now. We say the segments are equal. Okay, for this one we say the segment. Circle theory we say the segments are equal. See, this segment, anytime we have segment, in the circumference they are equal. This is y, meaning they are equal. This is x, meaning they are equal. Whenever we have this, they are equal. Is that okay? So the one that is sharing one arc, the angles are equal. They are sharing this arc. Okay? But they are not on this line. So the segment theory is this type of circle theory is known as the segment theory, right? It says that any two angles in the circumference of a circle that are formed from the same two points on the circumference are equal. They are formed from the same 2 points are equal. Is that okay? So angle x is x, angle y equal to angle y also. So let's apply this one. Let's say apply. It says find the value of theta in the diagram below. Give me reasons for your answer. Theta is here, so we have to find any angle that share the same segment with the theta. Which angle is on the same segment with the theta? We have to find. Remember, this is the diameter, this line. And any angle on the circumference, resting on this diameter is 90. This place is 90 degrees. So we can find here, because we know 12 and 14. If you add them together, you get 26, right? You get 26. So 26 plus 90, you get 116. Take it away from 180, you get this angle. This angle here. So 180 minus 160, minus 120, you get, minus 110, you get 70. So minus 6, you get 64. So this angle will be 64, if we're not mistaken. Okay? So likewise, we can find here. I found here to be 64. I can also find here. You know why? Because here, the whole of this is 90. Because it's sitting on this diameter. It's resting on the diameter. The whole of this is 90. And here is 73. So I get 163. So I'll find here to be 17. 17. So I find here to be 17. Right? I find here to be 17. So you find all the angles, then you'll be able to get this angle. Angle at the center is twice the angle at the circumference. See? Here is 17. I just verbally explained this. But if you want us to draw, we can draw and show it. Here is 70, here is 64, here is 90, here is 90. So you literally found almost every angle. So theta will be what also? 17. Because why is this angle theta 17? Because they are both, you see, with this arc, both of them are on this arc, they are both angles on the same segment. Any angle on the circumference sharing the same segment, they are equal. They are sharing this segment, both of them. So this theta is 17, and this is 17, this angle will be 17. Is that okay? Are you with me? So what is for us to find is to find this angle. The angle that this theta is sharing with. It's sharing the same segment with this one. So the moment we're able to find this angle, then we will find this angle theta. Are you with me?
Yes.
Okay. Do you understand that one? You want me to draw it and we solve it?
Yes.
You want me to draw it? Eh?
Yes.
Okay. Okay, the draw is a bit complex. First of all, we draw a cyclic quadrilateral. Okay. I think it's not complex. We draw a diameter. We draw a cyclic quadrilateral. We draw a diameter. Okay. Now let's see. Question number 4. Wait just a minute. It's reconnecting. Okay, while it's reconnecting, we keep our explanation. Okay, we draw a cyclic quadrilateral, we draw a diameter on it, then we draw a triangle. Okay. So we simply say A plus 26, A plus 26 plus 90 plus 90 degree is equal to 180 degree. Why? Because it's a triangle. It's a triangle. It forms a big triangle. This one, this one, this one. So I have two angles here. I can simply add them together. I get the value here of this angle. And then I already know this is 90 because any angle of the circumference standing of the diameter is 90 degree. I already know that rule, that any angle of the circumference that is standing of the diameter is 90 degree. Is a rule in circle theory. There, I don't know here, so I call it A. So A plus 90 plus 20 is equal to 180. So I can find my angle A simply, and then I move on. So A plus this, I get 116, 116. Right? 90 plus 20 will give you 110, right? 110 plus 6 become 116. So we get 116 equal to 180. Equals to 180. So when you subtract, A will be what? You subtract 160 from both sides. I want to jump that step. I presume we know. Subtract 160 from both sides. You get A remaining on the left. And then on the right, 180 minus 116. You get what? First, you can say 180 minus 110. You get 70. 70 minus 6. You get 64. So A equal to 64. A equal to 64. If you are not using calculator, if you are using calculator, just say 180 minus 116. You get 64 degree. So this gives us 64. This angle here. This angle here equal to 64. So I can write 64 here. This angle A. Where we wrote A is 64 degree. Okay, now we want to find here. We already know here to be 73. This also form another big triangle. Look at this. It also form another big triangle. Also form another big triangle, and it's also standing on the diameter. So this angle will be 90 degree. This whole angle will be 90 degree. Why? Because it's an angle on the circumference. It's an angle on the circumference that is standing on the diameter. It's standing on this diameter. So it's also 90 degree. Angle on the circumference that is standing on this diameter is 90 degree. So here. So I can call this place angle B. I can call this place angle B. Let's use a different color. I can call here angle B. So simply now I can say B plus 90 plus 73 equals to 180 so that we can find this angle B. So we say B plus 90, B plus 90 plus 73, or B plus 73 plus 90 equals to 180. Equals to 180. So if you subtract, if you add this and this, you get 163, right? B plus 163, B plus, add 90 and 73, you get 163. So B plus 163 will give us 180. We get 180. We get 180. So if we subtract 163 from both sides, then we get B to be what? 70 degree. We get B to be 70 degree. Now, remember they say we should find this angle. Now I'm saying, because the angle of the same segment, angle B will also, and since this angle B is 17, this angle theta will also be 17. The angle of the circumference that are on the same segment. Angle on the circumference that are standing on the same segment. These angles are equal. Angle of the circumference that are standing on the same segment are equal. So angle, since here is 70, the theta they ask us to look for, hence theta. See this, they want us to find here angle theta, this one. They want us to find this angle theta, right? Now they are standing on this segment. You want me to shade the segment, this place? Okay, this angle on the circumference, this one and this one, they are both on the circumference. This one is not standing on this one, it's standing on another side. But if you look at this segment, there are two angles standing on it. This angle and this angle, the one called angle B, the one we got 17. This one, this one. This one, angle B, the one we got 17, and angle theta, they are both angles standing on this segment. They are standing on this segment. Angles on the same segments are equal. Okay, that's the theory, that's the segment rule. Angles on the same segments are equal. Angles on the circumference standing on the same segments are equal. So if here is 17, here will be 17 as well. So theta will be 17 degrees. Are you with me? The how you ask me is because of the rule. The angle on the same segment are equal. Angle on the circumference that are standing on the same segments are equal. So angle theta will be equal to 70 degrees. Are you with me?
Yeah, I understood the first part. Like why, how, like I know it's the same.
Okay, I take you to the segment theory. Let's go back a little bit to the segment theory. Now, you see, this is whether they use arc or segment, same thing, okay? Because to have a segment is just to draw a line here, a chord, and then you shade. Okay, when we have an arc, it's same as we automatically we already have a segment, because to have a segment is just to draw a chord here. Now we say the angle on the same chord are equal. You see here y is same as this one. The reason is because they are standing on this segment. And then if you flip around, if I draw an arc on the top, sorry, not an arc. If I draw a chord on this place, I can shade the segment on top. And then you can say angle x and x are equal because they are standing on this segment, on this top segment. Are you with me? Do you want me to draw? Let me draw this one and illustrate. Okay? Maybe that one will give a better clarity. Question number 5 or something. Are we together? This is an arc, right? If I want a segment, I will just draw a chord. The segment rule says that angles on the same segments are equal. Angles on a circumference sitting on the same segments are equal. Now this angle is sitting on this segment. The root base is this segment. If you trace this line down and also trace this line down, that makes the angle. The two lines are sitting on this segment. On this segment. So if I call here angle A, and if you trace for this place, if you trace this line down, and you trace this line down, they're both still on this same segment. So since this angle is sitting on this segment and this angle is sitting on this segment, the rule says they are equal. So here will also be angle A. What I mean by writing A here, it means if here is 40, here will be 40. If here is 80, here will be 80. If here is 60, here will be 60. Why? Because it's a segment rule. Angles on circumference that are sitting on the same segment or bounded by the same segment, they are equal. Are you with me? Do you understand that now?
Yes.
Okay. If you do the segment this way, and you want to know, you also draw for angles, the corresponding angles, you also, it's same rule. If I have the segment here, then the angles here, these two angles, will be sitting on the same segment. For example, let's use a different color. For example, if we use the black color, if I draw a segment up this way, if I show a segment here, because to have a segment, once you have an arc, is just to draw a chord, you have a segment. So this is a segment. Then the angle here, this angle, this angle is sitting on this segment or up, and this angle is also sitting on this segment. So if here is angle X or angle B, here will also be angle B. Why? Because they're both sitting on this segment. Because they are both sitting on this segment. Do you get that? So that's what we mean by angles sitting on the same segments are equal. Now I take you back to this problem. Now if you look at this angle theta, it's sitting on this segment. Why? Trace this line down. Trace this line down. Is on this segment. Trace the second line for this angle down. You can see it makes up this segment. It's sitting on this segment. Now look at angle B. Angle B, trace this line down. It's for this segment. Trace the second line down. So it's also on this segment. So since the angle B and angle theta, we already found B to be 70. You understood how we got B to be 70. What you don't understand is why is this angle theta also 17? Because they are sitting on the same segment. So if this is 17, here will be 17 because it's also sitting on this segment. Angles that are sitting on the same segments are equal. That's the segment rule. Angles on circumference sitting on the same segments are equal. Do you get that?
Yeah.
Okay. Now let's see from that these questions if we can get more to illustrate. Okay, we've solved this question. We solved this question, I think. Okay, I think the last one they want to show us now. I think this is the last property or second to last property, if I'm not mistaken. Probably last property. Okay. Okay. This rule says this is for alternate segment theory. It's called the alternate segment theory. The alternate segment theory says that any angle on this target, see this angle, target to this chord, will be equal to the one in the opposite side on the far alternate side. So this one will be equivalent to this angle, this exterior angle. This one, this exterior, will be also equivalent to the far angles in the interior. So this is called the alternate segment angle. We're going to draw this, so probably you can do. You need a tangential line. Then you draw a triangle. You draw a triangle on the circle, and then the angle with the tangent here will be formed on the other side, on the opposite side or the right side. The one on the left, the tangent on the left on the right will be equal to the interior angle on the left. The right with the tangent will be same with the left, the interior angle on the left, far interior angle on the left. Then the exterior angle on the left will be equal to the far interior angle on the right. So this is the alternate segment theory. So to illustrate this is to show this. Question number 6. So we have a circle. We have a circle, and then we have a tangential line. We have a tangential line, a line that meets the circle. Okay, we have a tangential line. Then we have a triangle. We have a triangle. Okay, what this rule is saying, the ones that are same, I will use same color to illustrate it. Okay, this one on the right, the exterior angle, the tangent and this triangle. This one on the right will be same as this one on the left. The interior angle on the left, phi interior angle on the left will be same. So this angle, okay, the exterior angle here with the tangent will be equal to the interior on the far left. Then, using another color to illustrate this one, maybe dark blue or something. This angle, exterior on the left, will be equal to the far interior on the right. Do you get it? Do you understand this? Hello?
What?
Do you understand this? Do you hear what I was explaining?
Yeah.
Okay, so
Yes.
let's find probably a problem. We give a better clarity. Okay, you see, whatever we have here will be equal to what is here. Okay, so here is same as here. So if here is same as here, remember angle at the center is twice whatever is here. Okay, so then we can find the value of x. Let's see 2x plus 5 was the angle here, is equal to here, 2x plus 5. Right? So once you get that, angle at the center is twice whatever angle you have in the circumference. Okay, so you cannot use angle at the center to solve this one. So let's solve this question. Let's solve this question. In case you find the value of x, state any angle fact and theorem that you use. Okay, let's do this one. We draw this first. Okay, we can actually use this same diagram, I think so. Here's the center. So we draw a line, the radius to this place. We draw a radius also to this place. Okay, they've given us, let's see what they've given us. 2x plus 5 here. So here we have 2x plus 5. And here we have 5x, I think 5x minus 2. At the center, angle at the center is 5x minus 2. So this one, angle at the center, I write O here, center O. This angle is 5x minus 2. 5x minus 2. Now they want you to find the value of x, probably. Find x. And state any theory you use. So we're going to use the theory we learned just now, that the exterior angle on this side is equal to the far opposite interior angle here. So this exterior angle, 2x plus 5, will be same here. So I'll write it with red pen. I'll write it with red pen. So 2x plus 5 on the exterior on this place equal to the angle here, which is, so meaning here will be 2x plus 5. 2x plus 5. It's an angle, it's a rule. It's a rule, okay? Why? Because it's a rule. The exterior angle here is equal to the far opposite interior angle on the left. So this is 2x plus 5. It's called the alternate segment theorem. The alternate segment theorem. Okay? Now, have we used that rule? The first one is alternate segment theory. That's the one we've used. The exterior angle on the right equals to the far interior angle on the left, which is the alternate segment theory. So I write abbreviation AST. Alternate segment theory. That's the rule. Because in angle properties, sometimes they ask you to give reasons or give the rule that you use. Okay, that's the first rule. The second rule is that you now see angle at the center what we treated in the previous class. Angle at the center, angle center equal to twice angle at the circumference, right? Angle center, meaning angle at the center, is equal to twice, that's twice the angle at the circumference. So this is another rule, circumference. Okay, I stop here. I stop this rule here. Okay, so we apply the rule. So angle at the center is what? Angle at the center is 5x minus 2. Look at it. Angle at the center is 5x minus 2. So I write 5x minus 2. 5x minus 2 is equal to 2 multiplied by, so if you want to multiply, you can just simply put a bracket. 2 multiplied by the angle at the circumference. What's the angle at the circumference? 2x plus 5. So you write 2x plus 5. Let's use another color to itemize this. 2x plus 5. So it becomes a simple equation which we're going to solve, and then we find the value of x, which they ask us to find. And if you find the value of x, you can find the angle in each place. Find the value of x. The question can ask you, find the value of x and find each of the angles. Okay? Now, so we just simplify. So here, on the left, we have 5x minus 2. 5x minus 2 is equal to, we expand this bracket. 2 times 2x, we get 4x. 4x. And then 2 times 5, we get plus 10. 2 times 5, we get plus 10 when we expand the bracket. Then we collect like terms. So I bring the x, the 4x to come and meet the 5. And when it's coming here, it becomes minus. So I have 5x. I have 5x minus 4x. 5x minus 4x equal to 10. Negative 2 on the left, bring it to the right, become plus 2. 10 plus 2. So it becomes 12. So 5x minus 4x becomes x. Like 1x, we don't write the 1, it means x. Just like you say 1 orange. No need to say 1 orange, just say orange, and orange. Okay? Equal to x. So 5x minus 4x equal to x, and 10 plus 2 equal to 12. So x equal to 12. Now once you found x equal to 12, they might ask you to tell what is the angle in each case. X is equal to 12, we found x. They might stop at x, finding x only. So they might just stop there, but they might also want you to tell the angles. It becomes easy. So to find the angle at the circumference will be 2 times 12. We got 12, right? S equal to 12. So you say 2 times 12, 24. That's 24. 24 plus 9, 24 plus 5, it becomes 29. So the angle here is 29. The angle here is 29. The angle here is 29. The angle here, this angle is 29. So it means the angle here is also 29. The angle here is 29. Now to find the angle here, 5 times 12, 60. 60 minus 2, 58. So the angle here is 58. Of course, because 29 times 2 is 58. So the angle here is 58. So that's it. If they want you to tell the angles after you finish solving the value of x, you just substitute the value of x into those equations and you get the angles. Okay, that's for that problem. So have you been writing these ones? Have you been writing? Okay, so let's see if there is any other law we need to treat. If there's any other one, they've treated this one and they got x equals to 12. Okay, because this question they just want you to find the value of x equal to 12. But I'm just telling you in the IGCSE, the question might go a bit further by saying find the angles after you found the x equal to 12. Okay, so let's see if with area perimeter, I think this is different. So I think we finished the circle theory because this has our area perimeter. Is that okay? So we